Hello viewers, I am Kausalya. Today we are going to discuss about gate questions related to signal flow graph. The first question is construct a signal flow graph for the set of equations shown below. So these are all the equations. So totally you see we are having 5 equations, right? So here just look at the values of x here, right? Because H always denotes the elements in feedback loop. So totally how many elements are present here? So x1, x2, x3, x4, x5 and x6, right? Not more than that. So x1 to x6, right? So totally there are 6 nodes present in the signal flow graph. So the first step is you initially draw the 6 nodes, right? And mark them accordingly x1, x2, x3, x4, x5 and x6, right? Now we start with the equation number 1, that is this is our first equation, right? So x2 is given by x1 minus x6. So you see this is our x2, right? So x2 is nothing but, just for our reference I am writing here, x1 minus x6, right? So this is our x1, right? And we need minus x6. So here is our x6, right? But we need a minus x6. So the thing is you just draw a graph from x6 to x2, right? And here in this path the gain is equal to minus 1, right? So to this x2 we are having an x1, and here this x6 will get multiplied with this minus 1, therefore we will be getting x2 is equal to x1 minus x6, right? So the first equation is over. Next jump to the second part, that is x3. So x3 is given by g1 into x2. You see, again let me write the expression, then it will be easy for us. So g1 x2 minus h2 x4 minus h3 and x5, right? So here you see that is x3 is given by this. So x3 is g1 x2. So here I am having x2, right? To this x2 I am giving a gain of g1 here. Therefore, that is the g3, the incoming signal is x2 g1, right? So this is over. The next thing is minus h2 into x4. So this is our x4, right? So here we are having a minus h2, right? So therefore draw a loop, and here the value of this gain is, it is minus h2, right? So when you multiply, this will be minus h2 into x4. And finally here we are having minus h3 x5, right? So from x5 we should include a feedback element, that is feedback gain of minus h3. So again from x5 to x3, okay, you draw a loop like this, and here the value of gain is minus h3, right? So finally we had drawn the expression, that is we have drawn the signal flow graph for the respective expression. You see x3 is g1 x2. So to this x3 the incoming signal is g1 x2, and another incoming signal is minus h2 x4, and another incoming is minus that is minus h3 x5, right? Now equation number 2 is over here. Now again look at x4. So this x4 is given by g2 into x3. So here lies our x4, right? So from x3 it gets multiplied with g2. So here I am writing g2. Then the next thing is from h4, from x6 there is a minus h4. So this is your x6 and this is your x4, right? Now we are framing expression for x4. So from x6 to x4 you just draw a line, that is draw a path, okay? And here the value of signal which is included is minus h4, So here it is minus h4, right? So again you see x4 is given by g2 x3, so x4 is given by g2 into x3 and again minus h4 into x6, right? Now x5 is given by g3 into x4, so this is our x5 and this is our x4, right? So here we are introducing the gain g3. And finally, x6 is given by g4 into x5. So this is your x6 and this is your x5, and here we are introducing the gain g4. Right. So finally, this is our signal flow graph for the given expression. Right. I hope you people are clear with this. Depending upon the number of values, that is the different values of x1 and x2, we have to fix the nodes. Once the nodes are fixed, then it is easy. We can add the extra loop according to the values given in the expression, right? So first problem gets over here. Let's proceed to the second one. So our second problem is, consider the pair of equation of a system. Okay, these two are the equations. Again, the signal flow graph of the system will be. So here, how many x values are here? You see x1, x2, x3 and x4. So totally 4 nodes are present. Okay, draw 4 nodes and mark them accordingly. Right. Then again, as usual, consider your first expression. That is, we are going to draw signal flow graph for x2. So x2 is the main node, right? So here x1 gets multiplied with t12. So here I am having x1 and here there is a gain of t12, right? And next thing is, this x2 is related with x3, right? So from x3 to x2, draw a path. So what is the gain here? It is t32. So here the value of gain is t32, right? Now look at the second equation. So here again x3, right? So x3 is our main focus now. So x3 from x2 it is, that is x3 is t23 times of x2. So here I am having x2 and here is our x3. So what is the gain here? It is t23. So here in this path, introduce a gain of t23. And the next thing is, again x3 and x4 are interconnected, right? So again to the x3 from x4, right? That is a gain path of t43. So from x4, you have to draw a path to x3 and here the value of gain is, it is t43, right? So finally, this is our signal flow graph. Right, so in this path, even you can consider it as 1. The gain value is 1. Clear here? The same thing, but when compared to the previous problem, this is quite simpler one. Then we are proceeding with the third problem. The signal flow graph of a system is shown below. The number of forward paths are, right? So here the signal flow graph is given. We have to count the number of forward paths. So as we all know, the forward paths, it starts at one node and it proceeds forward. Okay, it just goes forward and it will end with some other node, right? So here you see we are having 6 nodes together. So let the first forward path be, I am considering from x1 to x6. That is a straight line. You see here the arrowheads are proceeding forward. So this is our first forward path, right? Then we have to check for some other forward path, right? As we all know, the forward path is, it should proceed forward, okay? So here again you see, you start from this x1 to x2 and here there is a forward path arrow, right? So you just go by this way and you can go straight like this, right? That is x1 to x2 and x2 to x4 and x4 to x5, x6. So this forms the second forward path, right? And again you see x1 to x2 and from x2 to x5 there is a path. So we can go by this way and finally reach x6. So this forms our third forward path, right? So apart from this, again check for some more forward paths, whether it is present or not. So here you see, when you look at this, this is a feedback, okay? It is not proceeding forward, it is coming back. Again, when you look at this path also, it is coming back. And here, when you go like this, you see the straightforward path should never consist of any nodes, okay? Any closed loop. So here, we can't take this as another forward path because that is at x4 we are having a loop, okay? Since the name is forward path, it should contain only forward paths. No loop should be included in the forward paths. So for the given signal flow graph, the number of forward paths are 3, right? So now the fourth problem is, the signal flow graph of a system is shown below. The number of individual feedback loop, right? Here we are going to calculate the number of individual loops here. So here again, as we all know, a loop is nothing but it should start at a node and it travels some distance and again come back to the same node. That is, a closed path should be formed by a loop, okay? That is known as a loop here. So here in this case, when you look at this graph, you see here this is a loop, right? Because it starts at x2, travels to x3 and again come back to x2. So this is your loop, and again this is your another loop, right? And again this is another loop, though it starts and ends at the same node, right? That is, it is not traveling to any other nodes. This is also considered as a loop here. So you see 1, 2 and 3, right? So apart from this, can you check whether there are any loops present in this forward, that is in the signal flow graph? So yes, there is one more loop. That is, you see, when you look at this node, you see here we are having a path that reaches x4 and again x3 and finally it ends with x2. So this forms the fourth loop. So total number of loops present in this given signal flow graph is totally 4, right? So that is what I had drawn here individually, right? Now the next thing is, the signal flow graph of a system is shown below. Calculate the number of forward paths. Again the same thing, right? The forward path, the arrows should always proceed forward, okay? So here in this case, again you see this is our first forward path, right? It starts at x1 and it ends at x5. Then the thing is, you see, this forms our second forward path, right? It starts at x1, travels to x2 and it reaches x4 and finally x5. So this forms our second forward path, right? Then when you note carefully, you see the third forward path is, it starts at x1, reaches x2, reaches x3 and finally it reaches x5, right? So totally, how many forward paths for this signal flow graph? This signal flow graph has 3 forward paths, right? So here comes the end of this problem. I hope you people are clear with this. If you have any doubt, let me know in the comment section. Thank you.